Let us evaluate the integral of secant to the power 9 of x when dealing with an integral of secant and your exponent is an odd number. You would first need to factor out 1 secant squared of x, making this integral of secant to the power 7 of x multiplied by the factored out secant squared of x of dx, which is just this. And the reason why we had isolated secant squared of x here, it is because what our exponent here is an odd number, so we need to compromise first. And we need to integrate this by parts. Just a recall for the formula of integration by parts. The integral of u multiplied by dv, or the derivative of v, would be equal to u multiplied by v minus the integral of v multiplied by the derivative of u. And this is where our factored out secant squared of x comes to play, wherein this would be a part of the dx itself, making this our dv. And for this one, secant to the power 7 of x would be our u. And according to the formula, we need here the v and the du. So for this one, let's get the du first. U in this case is equal to secant to the power 7 of x. And in order to get du here, we need to take the derivative. So the derivative of secant to the power 7 of x, this is chain rule, focus on the exponent first. So this would be 7 secant, 7 minus 1 would be 6 of x. And multiply this by its inner function, which is secant to the secant of x, wherein the derivative of this would be equal to secant of x multiplied by tangent of x of dx. Let's just put that later on. And let us simplify this first. So the full du value in here would be equal to 7. You can see here that secant and secant here can be multiplied against each other, which makes this secant to the power 7 of x, and what's left here would be the tangent of x. And whenever you're taking a derivative, multiply this by dx, since it is respect to x in here. So this would be our du value, and what's left here would be the v. In our case, dv right here would be equal to secant squared of x of dx. In order to get the v in here, just take the integral of it. The integral of secant squared of x would be equal to tan of x. Now that we had our values in here, let us now substitute it according to our formula. In our case, first up would be u multiplied by v. U here in this case would be secant to the power 7 of x, and v here would be equal to tangent of x minus the integral of v du. V in this case again would be tan of x, and du right here would be equal to this value. Let me just erase this because we had already used it. And now that we had our formula, we can now erase this. And focus on what we have now. Firstly, let us simplify this expression. You can see here that there are two tan of x, so you can combine them together in order to make a tangent to the power, tangent squared of x, I mean. And what we have here is 7 secant to the power 7 of x. Since what we have here is a coefficient or a pure number, we can actually put this outside the integral. So this would be 7 integral of tan squared of x. And what we have left here would be the secant squared, secant to the power 7 of x, and the dx itself. After simplifying your expression, for the first part, which is this, you cannot simply solve this any furthermore. And we will just focus on the integral in the second part. For this one, we need to first put tangent squared of x according to its trigonometric identity, because whenever you are dealing with an integral, you would want to have a singular trigonometric identity or a function. So we can say here that we need to get rid of tangent squared of x. According to the trigonometric identity, secant squared of x would be equal to tangent squared of x plus 1. And since what we need here would be tangent squared of x, we would need to put 1 to the other side, which makes this tangent squared of x be equal to secant squared of x minus 1. You may ask that why would we not just use secant squared of x on the secant? It is because our exponent here is an odd number, and what we need here is a secant squared, which is an even number. We cannot simplify this, so we will just use the tangent squared of x in order to put all values here as secant. After that, let us just substitute it. Tangent squared of x, putting this one, and copy the rest. And after that, we can distribute this one to the parentheses. This should be secant squared of x multiplied by secant to the power 7 of x would be secant 9 of x. Minus this one, it will be negative secant 7 of x of dx. After that, we need to split this integral into two parts. So for this one, it would be negative 7 integral, which is this one. And for the first part, which is secant to the power 9 of x. And don't forget the dx in here. And for the second part, negative 7 multiplied by the negative in here would be a positive 7 integral of secant to the power 7 of x of dx. And if you had reached this stage, or there is a sign here in which you would want to do this now, you can see here that we have an integral of secant to the power 9 of x, which is actually our original problem. So we would need to get rid of that. And what we had recalled in here is that the integral of secant to the power 9 of x of dx is actually equal to this one. We had just modified its function. And so we can say that the integral of secant to the power 9 of x of dx is actually be equated to this function. And the reason why that we would need to equate this to each other, it is in order to get rid of this value right here. And now, for this one, since what we have here is a negative 7, we would need to add plus 7 secant to the power 9 of x of dx to both sides. And for this one, it is an automatic 1 value in here. So 1 plus 7 would be 8 integral of secant to the power 9 of x. Be equal to, just bring down these two values first. And for this one, negative 7 plus 7 would be equal to 0, so it would be cancelled out. And what we have left here would be this one. And we are left with this equation now. 8 integral of secant to the power 9 of x of dx would be equal to secant to the power 7 of x tangent of x plus 7 integral of secant to the power 7 of x of dx. We can now erase this equation of ours. For this one, since in our problem, we only need an integral of this one, which means it only has a value of 1, we need to get rid of the 8 here. So, divide both sides by 8. So, this should be back to the original problem. Be equal to this one. We can actually put this as 1/8 multiplied by secant to the power 7 of x of tan of x. Plus, for this one, since what we have here had already a number of 7, it would be 7 over 8 integral of secant to the power 7 of x of dx. And now, the only thing that we would need to solve would be the integral of secant to the power 7 of x of dx. And you can see here that same as our original problem in here, it is also an integral of secant, and the exponent is also an odd number. So you can repeat the steps that I had did earlier in here, but I will not be explaining on how to solve this one because I had already explained it in my previous video. You can just check it out. And so I will just put the straight answer that I had solved in there. For this one, according to my video, the integral of secant to the power 7 of x of dx would be equal to 1/6 secant to the power of 5 of x tan of x plus 5 over 24 secant cube of x tan of x plus 5 over 16 secant of x tan of x plus 5 over 16 natural log of the absolute value of secant of x plus tan of x plus the constant of integration. This is the full answer that I had solved in my video regarding the integral of secant to the power 7 of x. So we can just substitute it into this equation right here, or the term. And our final answer right here would be equal to 1 over 8 secant to the power 7 of x tan of x. Oh wait, I forgot we need to distribute 7 over 8 in here, this coefficient. But let us simplify this first. Plus 7 over 8. And let's put a bracket which represents the full integral value of secant to the power 7 of x, which is all this. So it is that. And for your final answer, you can just distribute 7 over 8 all amongst the coefficient of this. And for your final answer, it would be equal to this one. 1/8 secant to the power 7 of x tan of x plus 7 over 8 multiplied by 1 over 6 would be equal to 7 over 48 secant to the power 5 of x tan of x plus 5 over 24 multiplied by 7 over 8 would be equal to 35 over 192 plus 5 over 16 multiplied by 7 over 8 would be equal to 35 over 128 plus 5 over 16 multiplied by 7 over 8 would be the same as this, which is 35 over 128. Natural log of the absolute value of secant of x plus tan x. And of course, don't forget to add the constant of integration. So this should be your full final answer regarding the integral of secant to the power 9 of x.